Imagine you've just won a card game, but something goes wrong. You find out that the game knows that you've won, but you didn't receive the reward. This could be caused by the dual write problem, where the game needed to save your win and also notify another system. When you make two network calls like this, one will eventually fail, and unfortunately it doesn't matter which order you make the calls. If we write the win to the database first, and that succeeds, but ultimately the process fails, we've recorded the win, but no other service was notified. If we change the order and publish to the card service first, we add the new card to your deck, but the database write could still fail. This is what the dual write problem is all about. Either way, there's a gap and the system still ends up in an inconsistent state. Now let me show you how the Outbox pattern can make this system more resilient. The game service and card service are different systems and they shouldn't share a transaction. So the first thing we need to do is to stop writing to two systems and write to one. In the same transaction that saves your win, you also insert a row into an Outbox table. We're not yet publishing this event, we're just saving it to a different table in the same database. One transaction, two rows, either they both commit successfully or the whole thing fails. But this actually presents its own challenge, at least once delivery. Introducing an Outbox table means we've added a background worker. When this background worker finds a new row, it will publish an event and then remove the row. But that's only if everything goes fine. What if we failed to publish the event? Perhaps it was a network issue. Well, we don't need to worry about that too much because the row stays, so it'll just get picked up next time. Now the worst case is no longer data being lost, now it's just a delay. But the case that bites when the worker successfully publishes but fails to remove the row. Because the row survives, when the worker restarts, it sees it again and publishes it again. The event will go out, just maybe more than once. At least once delivery is a pragmatic approach, but it means that your consumers are going to need to handle duplicates. It means that card service is going to get the event twice, and you're going to need to ensure that the player doesn't get two cards instead of one. That's what idempotent means in practice. Running the same operation twice gives you the same result as running it once. There's a nice example of this in our card game. We could flip the card from red to blue. If we run this over and over again, we're going to get a different state every single time the card is flipped. But if we specifically say set the owner to blue or red, then we could run that over and over and over again. If we choose blue, it will always be blue.
Always blue, always blue, always...
We may not always want to act on each event, so instead we will deduplicate them. Every event carries a unique ID. Consumers can track which IDs is already handled and skip anything it's seen before. That's the inbox pattern. It's the same idea, but on the receiving end. Now, none of this makes distributed systems any easier, but an outbox changes what failure looks like. Without it, the crash meant that nothing downstream knew about our win. But with it, the worst that happens is a duplicate event, and we can guard against that. Systems now get notified of the win, maybe twice, but never zero. Thanks for watching.